Hello, welcome to this lecture on biomathematics. In this lecture, we will basically discuss some kind of questions, miscellaneous questions that arise that typically students ask, which will help to see this course in kind of something that complementary to what many things that we learned, or something that we missed out, or something that some students would want to know. So, this kind of things, like as a miscellaneous things put together, this lecture is basically formed by putting together this kind of miscellaneous things. So, there will be like 2, 3, 4 things which are not completely unrelated, but with different questions we will discuss. So, we will go through these questions and or various things. So, and we will discuss those things. So, let us see what are the questions that these are some questions that some students typically ask. So, this is we will see this. So, the title of the lecture is questions and discussion. So, we will see what are the questions. So, the first question is related to the first part of the course, where we did a lot of plotting functions and we learned how to plot functions. And the question is the following: how can one plot functions using a computer? So, we learned how to plot functions using, so we learn using various mathematical techniques. How do we find minima, maxima, and how do we plot functions? We know how to take values and plot functions, but this all one should know. But in a day-to-day use, it is much easier if you could plot it using a computer and really use it for, let us say, a research purpose or some other purpose. So, to quickly see how would a function will look like. So, we will briefly discuss how do we plot some functions using a computer. So, to do this, we will discuss a software. So, there are many software available to do this plotting using a computer, and I will discuss one of them, and you can, there are many other things you can learn any of this, and you can do the same thing using many other things. So, what I will be discussing is something called GNU plot. So, the software name is GNU plot. It is an open source software, which means that it is available for you to download from the web for free. Anybody can download and use it. So, let me write it here. It is called GNU plot, and if you Google search for GNU plot, the first website that you will get, so Google search, the first website you will be getting is this. So, from there you can download this software and then you can install this software, and once you install, you can use the software. It is very simple, and you can plot almost any function that you want. So, first what I will be giving is a demonstration of how to do various things using these functions. So, we will see how do we plot simple function like x, x square, sin x, log x, exponential x, all the functions that we learned. How can we do this? This can also do many other things, like this can also do, for example, simple fitting. How do we fit a linear function? How do we fit something quadratic? For example, if you have some function which is some f of x, how do we fit that? We will see that in this lecture. So, the first part of this lecture will be a demonstration, a demo of how do we use this software called GNU plot. So, this is available. So, this GNU plot is available for Windows. If you are using Windows, Microsoft Windows, it is available for, like, so if you are using Microsoft Windows, it is available. If you are going to use some kind of Unix or Linux, it is available for GNU Linux. It is also available for Macintosh, Mac OS. So, it is available for pretty much all popular operating systems. So, this is what we will be using, we will be demonstrating today. So, let us see how do we demonstrate, how do we use GNU plot. So, see, please note this demo. So, in a typical Linux setup, if you take a terminal, you can take something called a terminal, and then you can see something like this. And if you type there GNU plot, you will get this. So, you will get something like this. This is what you will get in Linux or a Mac OS system. But if you are using Windows, if you download the GNU plot and install it, then double click on the icon, you will directly get such a window. So, if you install, double click on the GNU plot icon, you will get such a window. In such a window, what you have to do is just plot. So, let us see how to plot simple functions. So, the first thing we will learn is plotting a linear function. So, let us say simple thing, plot f of x is equal to x. So, let us say the first thing we will plot here is y is equal to x. Then we will see y is equal to x square. So, let us see, then we will see anything y is equal to x cube we can plot. So, let us see how these three things first. Okay. So, here you have to just say plot x. So, plot is the command and the function with a space you have to type the function. So, then enter and you get this. So, you see that it goes from minus 10 to plus 10 by default. So, this is minus 10, this is plus 10. So, by default you will get a linear function like this. Now, if you want to plot x square, you go back here and say plot space x. For square it is star star and 2. So, anything power x power n, you have to put 2 stars, that means power 2. So, x star star 2 means x square. So, for this what you have to just say that plot x. For this you say plot, everything is small letters, plot x star star 2. So, let us see what we get. So, you enter this. So, you type here egg plot. If you go to this terminal, you say plot x star star 2 and then enter. So, you get this. So, here you get a quadratic function like x square. Again there is a negative part and the positive part, and you get a curve like this. Similarly, for x cube, you have to just say plot, instead of star star 2, you have to say star star 3. So, you get x cube, which is a function like this. So, you know how to plot this function. 3 functions we learned: x, x square, x cube. So, now let us say I want to plot this only from 0 to 10. So, I want to plot this function only from 0 to 10. If I do not want the negative part, what I can do, for example, is, so let me make this slightly bigger. So, if I want only the positive part of it, I say that plot, put 2 square brackets, and in the bracket you put the range 0, 10. So, this means the range of x values should go from 0 and 10. So, x, and then you say x cube. So, this what does this command means? Plot square bracket 0, 10 x cube means plot the function x cube between 0 and 10 only. So, then you enter this. So, then you get starting from 0 only the positive part of it. Here also you can see that it is going from very large value 0 to 1000. Let us say I don't want this, I only want up to 100, the y axis. So, let us say y axis I want only up to 500. Then I can say that y axis also another second bracket you can put, then I can say y axis I want only from 0 to 500. Then only 0 to 500 will come, because the y axis is restricted to 500. So, this 2 square brackets, by putting values in 2 square brackets in this particular way, you can control the x range and y range. So, one more thing here in controlling, let us say you have to plot this function x cube and you do not care the x axis, you have to only control the y range. So, let us see this, say plot x cube without any range, it will plot the whole minus 10 to plus 10 by default. Now, let us say I want to control plot only from minus 500 to plus 500 in the y range. So, or let us say I want to plot y range only from 0 to 500. So, if I want to plot y range, if I want to control y range only, first put a bracket without anything, then put the second bracket and then put 0 to 500. What does this mean is that the first bracket says that x range, which you are not specifying. The second square bracket implies y range, which you are specifying. So, if you look here, the first square bracket you are not specifying anything, the second square bracket 0 to 500, which you are specifying, this is basically the y range. So, this is the range of x values, this is the range of y values. So, I am restricting only the range of y values. So, then I am plotting this. So, I get x axis I am getting, x range I am getting from minus 10 to plus 10, because I did not control it. But if I control y range, the y range only, the range goes from 0 to 500. So, this is the way to control range, x range and y range. So, let me say that here. So, controlling x range and y range. So, plot space first square bracket, second square bracket, the function you want, x, x square, x cube, whatever you want. So, this implies the x range, this x range will be specified here, y range will be specified here. So, if you say plot 0 to 10, the function, if the first square bracket implies the x range, this would plot x value between 0 and 10. But if you say plot, you leave the first square bracket without specifying anything, and then in the second square bracket, so leave the first square bracket blank, but you have to put the square bracket, but leave it blank. Then the second square bracket you put, let us say 100 to 200, the function you want, you write f of x whatever we want, whatever the function we want, then you will get the y range only fixed. So, this is the way to fix the y range alone. So, similarly, we can plot other functions. So, another way of plotting some other function is, for example, let us go back here and let us plot, how do we plot exponential function? So, the way to plot exponential function is e power a exp of x. So, this is a way of plotting exponential function. So, this is exponential function, which is again from minus 10 to plus 10, and if I want to plot it only from 0, I say 0 to 5 and I want to plot exponential function. So, I have 0 to 5 exponential function this particular way. Similarly, if I want exponential minus x, I can plot exponential with a minus sign here. So, exponential minus x, it will plot exponential minus x from 0 to x. So, similarly, you can plot log x, plot log x. So, again this will go from minus 10 to plus 10, but minus of log has no value. So, let us start from 0 only. So, let us say 0 to 5, so let us say 0 to 10. So, if you look here at 10, the value is 2.3 something. So, this means this is a natural log. So, just plot log x will plot the natural log. This is equivalent of ln, ln. So, this is natural log. If you want log to the base 10, you have to say log 10 x. You have to plot 0 to 10 log 10 x. This will plot natural log to the base 10. So, this will be log to the base 10, and at 10 the value will be 1. So, this is another way of plotting exponential. This is a way of plotting log function. There are many tricks that you can do. So, you can also plot, if you want to plot square root of x, of course, x star star 0.5 will do this. Then again you can control the range there. You can also say plot sqrt of x. I think this should work. Okay, yes, this works. So, sqrt of x will also work. So, this is a way of plotting square root, but if you want to plot some other like cube root or some other root, you have to use x power, like x power 1 by 3, x star star 1 by 3. So, you have to put a 1 by 1.0 by 3.0, and this will give you this. Okay, so, this particular way you can plot whatever value you want, any x power, anything, any exponential, any power you can plot in this particular way. So, another thing you would want to learn is plotting sin x. For example, plot sin x. So, this is the way to plot sin x. So, this will give you sin. Similarly, for cos x, you can say plot cos x. So, this will plot as cos x. So, the argument should be always x. It only detects x. You cannot say cos theta or cos p will not work. You cannot say cos p. This will not give you anything, because it says undefined variable p. It does not understand what p is. It always takes this as only as x. So, you have to give whatever in terms of x is the variable. So, cos x. Similarly, if you want cos inverse, you have to say a cos x. I think this is what cos inverse, I think. So, even sin inverse is a sin inverse x. So, similarly, you can plot many other functions. So, another thing is you can say f of x is equal to x power 4 minus x square, or let us say x power 4 plus 23 x. So, you can define f of x, then you say plot f of x. This will plot f of x. So, you can say this, but another something, some other function, then say plot f of x. This will give you a function. This is something we learned, some kind of double well. The well is very small here. So, I can say the y axis is only up to 100. So, I say the x y range, I say y range is only up to 100. So, I specify the y range. I should specify the y range a little more higher, and let us specify the x range also little down. So, I specify the y range is to minus. So, I want to specify the y range from minus 1000 to plus 1000 or minus 500 to 1000. So, if I specify the y range from minus 500 to 1000, you get a nice double well potential. So, what did we plot? We plotted f of x is equal to x power 4 minus 23 x square. So, this was our function. F of x is x power 4 minus 23 x square, and I plotted that function from minus 500 to plus 1000 f of x. So, I defined f of x in this particular way, then I plotted plot f of x, then that also gave me. So, this is another trick of doing this. You can play around this with this and get whatever you want. Another question immediately comes is, how do I plot a data function? How do I plot a function? Let us say data file you have file. So, we will now take so we can make a data file in your computer in the appropriate folder, the folder of the GNU plot where it is. So, and then you can go there and plot the data file also. So, we will see how do we do that. So, this is what I am going to demonstrate next. So, first we will see what you see on the screen is a data file. So, have a look at this data file. So, you have x axis 1, the y value is 3.1. So, typically if you do for example, an experiment, you will get such a data file 1, 3.1, 2.0, 5.8, 3. So, I name this data file as data1.txt. So, data1.txt is the name of this data file. So, if you are in a particular folder, let us say you are in the folder that where this data file is, there you take the GNU plot, or you put the data file in the folder of the GNU plot and say plot the file name with quotes. So, you can say quotes, single quotes for example, you can use either single quote or double quote, data1.txt. This will give you, then you can say with points, point size 3. So, this gave me data file like this. So, what did I do? Well, I did a simple thing. I said that plot data1.txt, the file name in quotes, okay, in single quotes, and with WP means with points, and I can specify point size 3, point type 5. So, this is, so even without this it will plot, it will be very small, but so this is very small which you cannot even see. That is why I said plot data1.txt. You can either use double quote or single quote. Then I say with points, with, I can type everything in detail with points, point size 3, point type 5. So, point type 5 typically means squares like this, filled squares like this, and you will get this. I can change this to point type 6, I will get something else. So, if I change point type 6, I get open circles. I can make it 7, point type 7, I get filled circles. So, this is a way of changing this. So, I can say point size, instead of 3, I can put point size 5, you will get huge points. So, I get bigger points. So, this almost looks like a straight line. I have another set of files here, data2.txt, which is another set of files. Let us plot this, plot data2.txt with point type 5, point size 5. So, this looks like not, it is like some curve. So, it is like more like a quadratic function. So, this now if you want to plot this with line, you can say instead of, you can say that plot data2.txt with line points LP, and you can say point type 5, point size whatever you want, let us say 3. You can also say line type 1 and sorry no comma, line type 1, line width 10 or let us say 5. So, you can specify the line type and line width just like point type and point size you said, and that will give you something with line and points. So, there is a line through that and there is a point. So, this is the way to plot data functions, data files. Now, GNU plot also can be used to fit some function. So, let me write it here quickly. What did I do now to plot data, so that it will be useful for you. So, to plot data, you have to say plot file name, whatever the file name, it could be just simple text file. So, whatever the file name with extension you can say, and you can say with points and specify point size 3 and you can even specify point type 1, 2, 3, 4, 5. There are various numbers. So, you can change this number 1, 2, 3, 4, 5 and you will get you can play around with. Then you can also plot the data file with line points, and you can say point size, point type, point size 1 or point type whatever 5, and you can specify line type 1, line width some number 5 or 3. So, this is the way you can use it for plotting various functions, various data functions and various data files. You can also use this for plotting, let us say, fitting for fitting data. So, we have a data file now. How do we get the best fit? So, that is the next thing that we will demonstrate. How do we get best fit from this, from a simple data? Let us look at the first data that we did. So, we had this data called data1.txt. So, if you look at here 1, 3.1, 2, 5.8. So, let us plot here first, plot data1.txt with point type 7, point size 3. So, this is almost looks like a straight line. Now, if this looks a straight line, if you know that this is a straight line, the way to fit is the following. So, first that you know that the function you want is a straight line. So, give a command f of x is equal to mx plus c. So, because this is the equation of the straight line, f of x is equal to mx plus c is the equation of the straight line. So, you say that f of x is equal to mx plus c, you enter that. Now, you want to know the value of m and c. So, the command is fit f of x space the file name you want data1.txt via m comma c. Fit f of x data1.txt via m comma c. So, if you give this command, you will get a lot of calculations here and you will get some values here. So, and it comes back, which means that the calculation is finished. It has done some calculation and it has generated some parameter. You can see that final set of parameters. So, m is equal to 3.025 and c is equal to minus 0.125. This is the parameters it got. So, then you can say plot the data file data1.txt with point type 5, point size let us say 4. Then you can plot the f of x with line type 5 and line type 1 and line size 4. Sorry, you can say f of x with line. So, you have f of x with line. So, this is the best fit. So, you can say f of x with line width 3. Okay. So, here you have this is the best fit. So, to do the best fit, let me do this once more. If you know the function and if you know the data file. So, let me do this. Let me clear this and take it again. If you know that the file to plot is data1.txt and if you know that this what we have to fit is a straight line, first you have to define a function f of x. So, define f of x is equal to m x plus c, m into m star x plus c. Then say fit f of x space the file name data1.txt via m comma c. These are the two parameters that we want to find out and enter. It will calculate the parameters and it will give you what are the final parameters here. And then to plot it, plot data1.txt with point type phi point size 3. Then you have to say f of x. This is the function that we now when you say f of x, it has already taken the value of m and c which you get here. So, it has already taken the value of m and c from here and then has generated an f of x. Then you can say that with line width 4 and that will give you this. Okay. So, you also learned how to plot, how to fit it. You can fit the same thing using instead of f of x equal to m x plus c, I can say f of x equal to m x square, some other function. So, let us see this. So, let us say you have data, let us have a look at it, plot data 2 dot txt with point type 5, point size 3. So, this will give you some function like this. So, this is the data 2. So, this looks like a quadratic function. So, let us fit a quadratic function to this. So, if how do we fit a quadratic function? So, to fit this, let us say f of x is equal to k into x square. So, I said f of x is equal to k star x star 2. So, k star x means k into x star 2 means k x square. So, now say that fit f of x data 2 dot txt via k. K is our parameter here. Okay, I have made a mistake, data 2. So, data 2 dot txt. So, it gives and it generated some k which is 1.00672. Then, now I say plot f of x with line width 3 and then data 2 dot txt with points, point size 5, point size 3, point type 5. This is the best fit. So, this is the way to do best fit. So, what we saw is how do we fit a function. So, let me quickly write here to fit you have to have a data file and a function. So, then the command is first you do define f of x, for example, is equal to whatever function you want, either m x plus m star x plus c, or you can say f of x is equal to k star x star 2 stars. So, let me write it, f of x is equal to k star x double star means k x square. Then you say fit f of x, then the file name, via the parameters. Here the parameter in this case m and m c. So, you can say m comma c. If you have more parameters, you can say m comma c comma something else. So, you enter, you done, then you get the final parameter. GNU plot will calculate this parameters m and c. Okay, now there is only one more thing we will discuss about GNU plot. So, one thing you would want to do is to learn how do we save a file from GNU plot and export it as either PostScript or PDF or any other format. So, the command to do that is set terminal. So, let us do this. So, let us say we are doing an exercise which is plotting sin x and saving it as. So, we take GNU plot and let us say you want to plot sin x and save it as a EPS file. So, the way to do is a set terminal PostScript EPS. EPS is a format, enhanced PostScript, encapsulated PostScript. So, this is a particular format which is used widely for printing and all that. So, let us save a file into this EPS format. So, you type the command set terminal PostScript EPS, then you say that plot. So, then you also say set output file name dot EPS, whatever file name you want. Let us say I want to say file 1 dot EPS. Set output set out file1.eps. That means you have to set the output file as the file to this file. Then I say plot sin x. So, the output will be saved in a file called file1.eps. So, if you just look for file1.eps, what you will get is this file which you just saved from this. What you will end up getting is just this file sin x. So, you will see that the sin x plotted, you will get the sin x plotted here. So, this is the way basically to do this. So, you got the basically you got the sin x of this plotted here. So, you can of course do this set terminal color and so move. There are many more things, but this is just an overview. You can do Google search and learn many more things. There are help files in the internet. My aim here is to just introduce you to a very simple software called GNU Plot, which is a open source free software which will help you to plot pretty much any function, do various simple things. And how do we use it? How do you use it can be seen from the internet. There are manuals, you can read them. I just gave you a very quick guide for you to start. You can use the help command. For example, here if you go to GNU Plot and type help plot, it will show you various things like plot, various things. So, you can use help, you can even help set terminal, it will show you how to use help set. So, you can use help files here or help files in the internet, or you can Google search pretty much anything you want related to GNU Plot, and there is a very wide range, a very large community of users. So, they will have almost everything given how to do this very simple. How do I save a file from GNU Plot? You do the Google search on that, you will get the answer, and that is the simple and dirty way of doing this, and you can use it. That is the way to start learning it, and I think you should use it. Okay, so this is one important thing that we learned, and we will quickly go through some other questions that people might have. Another thing is this doing calculation using a computer. So, this can be done. There are many softwares like Mathematica which will help you if you want to do many of these calculations using computer. I would not go and discuss how do you use Mathematica, but let me write here this software called Mathematica, which you can do analytical calculations using computer. So, this is a software which you have to buy, but therefore, it is not freely available. So, it is not an open source software. We would not discuss that in detail, but it is one software where you can do such calculations, analytical calculations, and you can do many other things numerically. You can do integration numerically. There are various numerical schemes. So, softwares like MATLAB will help you do things numerically. So, you can give a data file and do the integration numerically, or you can write programs. For example, there are like books itself called like numerical recipes, which will give you various numerical methods to do many of this calculations numerically. So, this is something which you would want to go and look at it, this programs, how do you do this numerically, because that in itself is a separate course, but I just want to mention that all these things, when you do you can, if you cannot do it analytically, you have a data set and you cannot do this calculations analytically, or you cannot do integration of a function analytically, or you cannot solve a differential equation analytically, you can do that numerically. There are numerical methods like Runge, Kuta and various other methods. So, one has to go and learn these methods, but the basic idea what we learned so far will be very useful for all this. Okay, so, now another question will be something like interpolation. What it means, there are various interpolation methods. Let us do a simple thing. So, let us say you have a graph and you have a function here and you have data points like this. So, this is what you get, you have an x and you have y. and you have y of x. And I know that this is the data points you get from an experiment, and there is an x value and there is a corresponding y value. There is this the x value and this is the corresponding y value. This is the x value and this is the corresponding y value. This is the x value and this is the corresponding y value. Now, let me call this x 1, x 2, x 3, x 4, y 1, y 2, y 3, y 4. Now, one simple question that might arise is that so here I have this table which is I got from experiments, which are basically x 1 and y 1, the values x 3, y 3 and x 4 and y 4. These are the values, corresponding values, and this is the table I got and this is the function I got. So, if I have some function like this, the simple question that might arise is how do I find what is the value of the function here? Let us say for this particular value of somewhere in between this, how do I get this particular point? So, if I know, for example, a table and I know this value 3 and I have 7, 4 I have, let us say some other function here, let us say 9, 5 I have 11 and so on and so forth. So, how do I get the corresponding the value? Let us say I want to get the value, what is for 3.5? What is the value corresponding to 3? I have corresponding to 3 I have 7, corresponding to, so this is x and y, corresponding to 4 I have 9, corresponding to 5 I have 11, but what is the value corresponding to 3.5? So, the simplest way of finding this is that to assume that between 3 and, so if you plot this, what do I have? I have corresponding to 3 I have 7, so I have a value here, corresponding to 4 I have 9, so 4 I have 9, let us say corresponding to 4 I have 9 here. So, this is my second point, this is 9 and this is 4 and this is 3 and this is 7. Now, the simplest assumption, so I want to know what is for 3.5, is it here? So, the simplest assumption if you make that it is a straight line between this and this, what does this mean is that if I know that if I assume that this is a straight line between this and then the value of this can be easily found. So, this means that the slope of this straight line m is dy by dx, that means 9 minus 7 by 4 minus 3, this is my slope. So, if I know the slope I can calculate, then I can just calculate the new value which is between this 3.5. So, let me call this x prime. So, then from what do I know? So, this is dy by dx. Now, I want to get this new value x prime and new value y prime. And what do I know? I know that x prime minus x and y prime minus x y, if I find out this, and the ratio of this, that is what I want to find out is x prime and y prime, and if it is a straight line, we know that the y prime minus y divided by x prime minus x has to be m, which is same as 9 minus 7 by 4 minus 3. This is the slope, 9 minus 7, 4 minus 3. So, here I know the value of this. So, this is my y 1 and x 1. So, this is my, for example, this is 7 and 3. So, then based from this formula, if I know x prime is 3.5, I can say that y prime minus 7 divided by 3.5 minus 3 has to be equal to 9 minus 7 by 4 minus 3. So, I have an equation, the only unknown is y prime. So, in this by solving this I can calculate y prime. So, what did I do? So, what did I do here? Let me explain this once more. So, we had x 1 y 1, x 2 y 2, and we know that y2 minus y1 by x2 minus x1 is the slope m, if you assume it is a straight line. And let us say I want to find out a point in between this, which is at corresponding to x prime, what is the value of y prime. So, if I know the x prime and if I want to get y prime, immediate thing we can say that this is also equal to y prime minus y 1 divided by x prime minus x 1. So, I know y prime, I know y 1, sorry, I do not know y prime, I know y 1, I know x prime, I know x 1, then I can solve this equation and get this. In the previous example, we had x prime is equal to 3.5. So, what is the corresponding value? We can solve this and you can get this. So, this is some kind of useful thing which people sometimes wants. It is a very simple thing, assuming this idea of slope which we learned. So, with this lecture, so these are some other simple questions which you would want to use, simple idea that you would want to use. So, basically the main thing of this lecture was to use GNU plot, and how do we do this plotting of functions using a computer. So, with this we had a quick demo of how do we plot using computer. With this I will stop today's lecture, and this is through this you learned how to plot use various functions using computer, and you can also, I just also told you that you can use computer for doing many of these calculations. But before using computer, one has to understand how all these things work, and that is what we discussed in this course. How do all this, how do we do this by pen and paper, and once we understand that, you can go and use computer for making things simple and faster, but the underlying ideas we should learn ourselves, and this is what this course I hopefully will help you. Okay, bye.